We'll take a quick minute to talk about how to interpret slopes when working with linear regression models. A physicist models how the temperature in degrees Celsius of a hot metal rod changes over time in minutes and produces the following linear equation. So we have here on the left our response variable of temperature, and to the right we have our explanatory variable of time. Which of these two numbers in the model is our slope? Well, if you guessed negative 3.2, you're correct. Our slope is always the coefficient that's multiplying onto our explanatory variable time. It's a little bit different than we're working with algebra. When we're working with y equals mx plus b, the slope is traditionally mentioned right after the equal sign. It is reversed in our statistical output we get from software packages. So here's the model. When we think about slope, when I ask students to think about it, they typically respond with rise over run, something they remember from their algebra class. And that's a great thing to think about when you want to interpret a slope. So we have negative 3.2, and we want to think about that as rise over run. And because this came from a statistical software package, it will not be in a fraction ever. So here's our negative 3.2. And what I'm going to do is force this into a fraction. I'm going to place it over 1. You can place any number over 1 and you haven't changed that number at all. It's still negative 3.2. But if we think about rise over run now, we can think, okay, well, I have a negative 3.2. So that actually means I'm going to fall 3.2. And then I'm going to run 1. So I'm going to fall negative 3.2 and run 1. So let's layer in the language of the problem, which is that temperature is our response variable. That'll be on the y-axis. And time is our explanatory variable. That's on the x-axis. So what I typically do is I kind of write the number over 1 as I have. I kind of shadow the variable names and the units. And then I take and I sort of circle around here. I'll take this first arrow and I'll say to myself, the temperature will decrease 3.2 degrees Celsius. I'm just talking about what the numerator is doing. I say decrease because it's negative. Then I will finish off and say, oh, for each minute or per minute. And that's the nice thing about having 1 in your denominator, because it'll be 1 minute. If, for instance, feet were in our denominator, it'll be per foot. So here it is on the next screen. We'll have the temperature of the metal rod will decrease 3.2 degrees Celsius per minute. It's a nice sentence to use to describe the slope in our model. You could also reverse the order of the two variables. Another way to say it is for each additional minute, the temperature of the metal rod will decrease 3.2 degrees Celsius. I hope this was helpful.